Hello, we're going to continue our video series on the history of the United States congressional apportionment problem. And last video we finished talking about the Alabama paradox, which we'll talk about more so, these weird paradoxes that could come up, using Hamilton's method. So Hamilton's method, don't forget, is a quota method. The benefits of it are pretty simple to explain, and as you go through the homework, it's a lot easier to compute the quota method, Hamilton's method, but there's some paradoxes that could pop up, like the Alabama paradox. So in 1910, Congress abandoned this quota method and then used a modified divisor method. And we'll spend some time in the upcoming weeks in class going over this, because this modified divisor method is definitely a lot more tedious, more difficult to compute, but some of those paradoxes will not pop up with the modified divisor method. So in 1920, this is the only time in U.S. history that no census-based reapportionment act was passed. Usually every 10 years. Before and after this, Congress passes a bill with a reapportionment. Sometimes the house size doesn't change. In fact, it hasn't changed in almost 100 years. But usually the number of representatives of each state could change a little bit depending on population changes. The reason that there was no census-based reapportionment act in the 1920s was most historians say it's prohibition. The politics of prohibition played a significant role. The Dries, there's the people that wanted their prohibition to prohibit the consumption of alcohol, would not support any proposal that gave the Wets, people that did not want prohibition to happen, more power, and vice versa. So this was a very divisive time in American politics, and most historians believe that this issue surrounding prohibition caused the United States Senate and Congress not to pass a bill reapportioning the house size and the number of representatives per state. Okay, today the current method used consists of the Census Act of 1929. So in 1929, that froze the house size at 435. So we have the same number of representatives now as we did almost 100 years ago. And that leads to some interesting consequences that we'll talk about in these videos. And then later on, we'll do a video series on the Electoral College that elects the president, and the fact that this house size is frozen actually might have some very important consequences in the last a couple of presidential elections. But until we get that, we'll focus on this apportionment. And then a couple years later, 1941, an amendment was passed that specified the method to be Huntington Hill. So right now, or in the last 80, 90 plus years, house size is fixed at 435, and we've been using the Huntington Hill method to allot the apportionment. So Huntington Hill we haven't talked about yet in this video series. They were both mathematicians. Huntington was a mathematician, Hill was a statistician, and they proposed what I'm going to call a unitless way of rounding. So Huntington Hill is a divisor method, so you do have to change the divisor if you don't get the correct house size. And again, we're looking still at rounding. Q is your quotient, your population divided by your divisor. Divisor is the number of people per representative. And n is going to be the rounding down, n plus 1 is rounding up. And it turns out Huntington Hill's method corresponds with that geometric method of rounding. Geometric method of rounding between two numbers. So if we look at Dean's method, we looked at a couple videos ago, the goal was the divisor. Which of these two proportions, the population divided by the bigger number, or the population divided by the smaller number, round up versus round down, what number is closer to the divisor? And that Dean ended up actually being the harmonic mean rounding. Huntington Hill took a different approach. When I said a second ago that this was a unitless system, they said, what if we divide everything by D? So instead of the target being the divisor, we're going to make the target 1. And that way that for each state and for each 10 years, basically, when you do when the Congress does reapportionment, they're always trying to hit that target of 1. But then they also have to divide out the population divided by the larger number over the divisor, and so on. So you round up to the next highest integer if d over p plus n, if this ratio is less than or equal to this ratio. Kind of a strange idea, but it was passed, and it's a way to get more equity between the larger and smaller states. And when this happened, we can go through some algebra and show that actually if you cross multiply right here, you get a d squared. You're going to cancel out the population proportions, and you're going to end up with that geometric mean, the square root of n times n plus 1. So the Huntington Hill, what we currently use is this strange geometric mean. And it's a way of dividing out to get a unitless representation. All right, so two math professors, this was 1982, Belinsky and Young, studies the State University of New York and at Johns Hopkins, proved the following theorem. There are no perfect apportionment methods. This is similar to when we talked about Arrow's impossibility theorem. There are no perfect voting methods with more than two candidates. This is the apportionment, I would say, analog. So any method that satisfies that quota rule can produce paradoxes. So any method that satisfies that quota rule, again, could bring in the Alabama paradox or population paradox. On the flip side, any method that is free of those paradoxes may violate the quota rule. So for our class, think the Hamilton method always satisfies the quota rule, but the Hamilton method could violate the Alabama paradox. If we were to take, say, Jefferson's method will never violate the Alabama paradox, but it could violate the quota rule. So unfortunately, these two mathematicians will prove there's no perfect system. But that doesn't mean there might be systems that are better than another one. All right, the modified divisor method first fixes the house size. Again, make sure the house size has to be fixed. And then seeks a divisor that when the state's quotients are rounded appropriately and sum, the house size is achieved. So again, this is, if you started the homework, this is the more tedious method, this modified divisor method. And notice right here, we've now talked about 5 different ways of rounding. Jefferson method, round down. Adams method, round up. So the least amount of representation, the most amount of representation. And then the 3 middle ways of rounding. Webster proposed the arithmetic mean. This seemed the easiest and the most standard way we do rounding. That was his reasoning. Dean argued for this harmonic mean, that this actually gets closer to the proposed divisor. And then our current method that we use in the United States, the Huntington Hill, where it uses the geometric mean for rounding. All right, so today the Census Bureau obtains apportionment using a priority technique of calculation rather than an ad hoc technique. It's kind of a cool video. Hopefully it'll come out well. I'm watching a video through a video. So here's a link to that video.
We, the people of the United States. The mandate for the census is right here. Just a few sentences into the Constitution. Representatives shall be apportioned among the several states, according to their respective numbers. Apportionment. The dividing of seats in the House of Representatives among the 50 states. But how does it actually work? Since the 1940 census, Congress has used the method of equal proportions, which follows this formula.
A sub n equals P over the square root.
Okay, don't worry about the math. Just think of the formula as an apportioning machine. First, the Constitution calls for each of the 50 states to have at least one seat. So, subtract 50 from the current House total of 435, and you have 385 seats left. Next, the apportionment machine ranks the states by population according to the census. Then the machine starts giving out seats. After each seat is distributed, the machine re-ranks the remaining states based on the formula. until all seats are distributed. This process ensures that each congressional district from Maryland to California has roughly the same number of people. In 1790, each House member represented only about 34,000 people. In 2000, each member represented on average 647,000 people. Since the first census, the decennial count has been the basis for our representative form of government. And as our country grows, the apportionment process ensures equal representation for all, just like the Founding Fathers planned. Apportionment, another gift from our nation's founders, who transformed the census from a tool of government into a tool of empowerment for the people.
All right, as a very quick summary of this method, again, according to the Constitution, each state gets at least one representative. So step one, each state gets one representative. And then attach a priority number to each state. And then award seats one at a time by party until the desired House size, currently 435, is reached. And right now, this priority number is apportioned using this Huntington Hill technique. So state population over the average. Again, this average right now is that Huntington Hill technique. But just to kind of look at some differences, in the last seat, this is in the 2010 census. 435, the last seat, equal proportions here. This is the geometric mean. So Minnesota actually received the very last seat. Notice there's definitely some change here. If you have the greatest divisors equal harmonic means, this is the Dean's method. And right here, the averages. Hopefully this will make more sense. Min, arithmetic, geometric, harmonic, max. And if we were to go to just the next seat, notice then it would be California, would be the Dean's method. Equal proportions, what's currently used would be North Carolina. All right, so in the next video, we're going to do a couple little ancillary things. We're going to talk about, I think, some interesting topics. There was a lawsuit a number of years ago when they changed the apportionment method that went to high court in the land. And then we'll talk a little bit about gerrymandering and some proposals to, quote unquote, fix this apportionment problem.